So in the previous video, we introduced the concept of the mole, not with regards to a furry animal, but with regards to as a number to count. We said 1 mole of whatever you're counting, be it coffee cups or argon atoms or oxygen molecules. 1 mole of anything that you can count is 6.022 times 10 to the 23rd of that thing you are counting. So what I have on this slide here are examples of 1 mole of different elements, all are substances. All of these substances are equal to 1 mole of that particular substance. And so looking at them, you think, well, that's a little odd. All of these are representatives of 6.022 times 10 to the 23rd, but they sure all don't look the same, and they sure all don't weigh the same. This metal is probably going to be weighing more than this orange solid, and this liquid, we know the volume of it, but all of these look different, even though they are 1 mole. That leads to the second definition of a mole that chemists use when dealing with compounds and chemical equations, is being able to relate this unit called the mole to a mass or a weight, something that chemists can easily weigh out in the general chem lab. So that second definition of a mole that relates to mass, to talk about that, we need to introduce this concept of molar mass. To determine the mass of an element and how many moles that is, we can use our favorite handy dandy table, the periodic table. We can look at the periodic table for an element, and using the atomic mass of that element, use that number, but in terms of grams, to say that that's how many grams are in 1 mole of a substance, of that substance. For example, copper. You look at your periodic table and you see that the atomic mass of copper is 63.55. If I had 1 atom of copper, 1 atom of copper, the mass of that 1 atom would be 63.55 atomic mass units. We talked about that atomic mass units in chapter 2. If I had a whole mole of copper atoms, 6.022 times 10 to the 23rd, it turns out that the mass of those copper atoms is equal to the atomic mass of that element, but just take off the AMU, the atomic mass unit symbol, and slap on a gram. So that makes things really convenient for us. We can use the periodic table, specifically the molar mass of an element, as a conversion factor. We can look at the periodic table, and just looking at the atomic mass for an element, we can say what that mass is in terms of grams if I have 1 mole of that substance. So writing the atomic mass in terms of grams per 1 mole, that gives you the molar mass of an element. And hey, if I can write something with a numerator and a denominator, then I can use it as a conversion factor, which is what we'll do here. So in this example, I want to know how many moles of copper are in 22.5 grams of copper. Write down what I'm given, 22.5 grams of copper. Write down what I'm looking for. I'm looking for moles of copper. I'm going to use the molar mass of that substance to go from grams to moles. I got that 63.55 number from the periodic table for copper. So I have written that molar mass as a conversion factor, and I wrote it so that my gram unit is in the denominator, my mole unit is in the numerator, so my gram units cancel. So in your calculator, 22.5 divide by 63.55 should give you 0.354 moles of copper. And just like we can go from grams to moles, we can go from moles to grams. If I have 3.8 moles of aluminum and I want to go to grams of aluminum, get my handy dandy periodic table, and I see that the atomic mass for aluminum is 26.98. So that means 1 mole of aluminum is 26.98 grams. I write that so my mole units cancel. So in your calculator, 3.8 times 26.98. What spits out of your calculator is 102.5 grams. That's the correct answer. Let's use this example, though, just to kind of review sig figs a little bit. If I wanted you to give me the answer to this, to the proper sig figs, I would say so. But according to the number of digits that I gave you as the given, how many significant figures should my answer have? My answer should only have 2 sig figs. So the way to properly write this number with just 2 sig figs would be best done in scientific notation, so specifically 1.0 times 10 to the 2. Another review for scientific notation as well. So that is the second definition of a mole, being able to use the atomic mass on the periodic table for elements to relate the mass of that element in grams for 1 mole of that element. In the next video, we're going to put both definitions of a mole together and do some more practice problems.